Hello everyone. Today in this video we're going to do section 4.1 on antiderivatives and indefinite integration. Antiderivatives are just the reverse of derivatives. So if I asked you to find the antiderivative of 2x, most people would say the answer is x squared, because the derivative of x squared is 2x. But what about x squared plus 3? The derivative of x squared plus 3 is also 2x. Or x squared minus 5. The derivative of x squared minus 5 is also 2x. So what we say is we say x squared plus c. We say plus c because there was probably some constant that when we took the derivative of it went away. That c is called the constant of integration. All of this is in the notes in the Chapter 4 Word document that is already on e-learning if you would like to look it up. There are other basic integration formulas you need to know. The derivative of 0 is always a constant. The derivative of a constant is that constant times x plus c. The most important one we need to know is the integral or the antiderivative of x to the n dx equals x to the n plus 1 as an exponent over n plus 1 as a denominator plus c. What this basically says is you're going to add 1 to the exponent and divide by that new exponent. This is the most common derivative we're going to be using. The nice thing about integrals or antiderivatives is this is really the only thing you're going to have to remember. The bad thing about it is there's a lot of algebra you may have to do to get it in this form. One other thing about integrals or antiderivatives, the integration symbol and the dx are a pair. They signify the beginning of your integration and the end of it. When you take your integral, both of them go away together. So they're either both there together to say take the integral, and they both go away together when you do it. All right, so let's do a couple of problems. Number 1, dy dx is 4x to the 7th. If we want to find the antiderivative of that, we're going to say y equals. Remember, antiderivatives or integrals are the reverse of derivatives. So the derivative of y is dy dx. The integral of dy dx is y. Then to take the antiderivative of 4x to the 7th, leave the 4, leave the x, add 1 to the exponent, which makes it 8 over 8 plus c. But that's going to have to be reduced. There are two different ways you can do this. If you want to say x to the 8th over 2 plus c, that's fine. If you wanted to write it as 1/2 times x to the 8th plus c, that's also fine. They mean the same thing. All right, number 2. If dy dx is x squared plus 3x plus 2, find the antiderivative of it. The nice thing about these is, just like with derivatives, we can break it up and do one at a time. So the derivative of x squared is hold on one second, eraser, is going to be add 1 to the exponent, pen. So x to the 3rd divide by the new exponent. Hold on one second, it's my first time doing this. So add 1 to the exponent. So x to the 3rd plus, divide by the exponent. The 3x, leave the 3, add 1 to the exponent, divide by the new exponent, plus the derivative, the antiderivative of 2 would be 2x. Don't forget your plus c. For this one, nothing can be reduced, so you can go ahead and leave it just like that. That is a perfectly fine answer for the derivative of x squared plus 3x plus 2 is x to the 3rd over 3 plus 3x squared over 2 plus 2x plus c. All right, next one, number 3, before we make it real interesting. The integral of x to the 5th plus 3x squared plus 4x dx. So like I said, the integral sign and the dx just show you where to start and end the problem. We're going to do everything in between those. So the antiderivative of x to the 5th would be add 1 to the exponent, x to the 6th, divide by it, plus 3x, add 1 to the exponent, you get 3, divide by it, plus 4, add 1 to the exponent, 2, divide by it. Don't forget your plus c. Now in this one, a couple of these can be reduced. So I'm going to make this x to the 6th over 6 plus x cubed plus 2x squared plus c. And that's going to be my final answer to this problem. All right, let's make a more interesting one now. What about number 4? The integral of 3 over x to the 4th dx. Well, as I said before, we cannot do it unless it is just x to the power. There is no such thing as quotient rule. So I'm going to have to rewrite this as 3x to the negative 4th dx inside my integration symbol. Now that it is just x to a power, now I can integrate it. So leave my 3x, add 1 to the exponent, negative 4 plus 1 is negative 3, over negative 3, don't forget your plus c. But remember, we cannot leave negative exponents in it, so we have to reduce this. 3 over 3 is going to give me negative 1. X to the negative 3 is going to be over x cubed. Don't forget your plus c. So that's the answer I'm going to be looking for. Let's do one more, and then we'll move on to some trig. So what about number 5? The integral of 2 over the square root of x. Hold on one second. Let me just go ahead and fix this. Erase. Tools, pen. 2 over the square root of x. I'm wondering if I'm doing a symbol wrong. Erase. Pen. All right. Let me do it this way. It doesn't like the check mark. Sorry about that. So the integral of 2 over the square root of x dx. All right, again, we're going to have to write it so that the x is not in the denominator. And as we did with derivatives, we do not like the square root symbol anyway. So I'm going to rewrite it as the integral of 2x to the negative 1/2 dx. So it's 1/2 because it's the square root, and it's negative because it was in the denominator. So now I can go ahead and integrate it. Leave the 2 on the x, add 1 to the exponent. So negative 1/2 plus 1 becomes a positive 1/2. Divide by the new exponent. So we're going to divide by 1/2 plus c. All right. So now we don't divide by a fraction, we flip and multiply. So 1/2 flipped is just 2. 2 times 2 is 4. X to the 1/2 power is the square root of x plus c stays. So that is the correct answer to the integral of 2 over the square root of x dx would be 4 times the square root of x plus c. All right. Also in the notes, which you hopefully have looked at, I have listed for you the antiderivatives of a few basic trig functions. So all I have done is taken the derivatives of the 6 basic trig functions and written them backwards. So the integral of cosine x dx is sine x plus c. The integral of sine x dx is negative cosine x plus c because the derivative of cosine x is negative sine x. The integral of secant squared x dx is tangent x plus c because the derivative of tangent x is secant squared x. I'm going to go over the problems for this in the next video. So watch that.